Alright guys, it's time for our Unit 1 review today. So let's look at our review. It says a company manufactures and sells shirts. The daily profit the company makes depends on how many shirts they sell. Right? So the daily profit, that's going to be a variable, depends on how many shirts they sell. So shirts sold is going to be the other variable. The profit in dollars when the company sells X shirts can be found using the function f of x equals 6x minus 50. Find and interpret the given function values and determine an appropriate domain for the function. Okay, so again, what this is function notation. The difference between this and this is I plugged in a negative 4 in place of x. So instead of writing f of x, I wrote f of negative 4. So what you need to do is you need to take this function, 6x minus 50, but you're not going to write x, you're going to plug in that number. So 6 times negative 4 plus 50, or sorry, minus 50. 6 times negative 4 is a negative 24, and then minus 50, that's going to give you negative 74. So meaning if the company sells negative 4 shirts, because that's the x value, which it told me how many shirts they sell is the independent variable, they will make a profit of negative $74. So does that make sense? If they can sell negative 4 shirts, which is not possible, they're going to make a profit of negative $74. No, that does not make sense in the context of this problem. Let's look at my second example. My second example, I'm looking at f of 12.5. So once again, I'm going to take this value and plug it in place of x. So I've got 6 times 12.5 minus 50. 6 times 12.5 minus 50 is going to give me 25. So meaning, if the company sells 12.5 shirts, they would make a profit of $25. So $25. Now, does that make sense? You cannot sell 12.5 shirts. Okay, so that's also not possible. So based on the observations above, it's clear that an appropriate domain for this function is going to be all whole numbers. All real numbers includes decimals, right? And it's not possible to make 0.5 of a shirt. So I need all whole numbers, meaning 1, 2, 3, 4, etc., etc., etc. All right, looking at number 4, right? Number 4, we're finding the domain and the range. Again, domain is the x value, so I'm looking across the x-axis. Range is going to be my y value, so I'm looking across the y-axis. So I'm scanning the graph left to right. I want to find the leftmost point. Bam, there it is, which is that point right there. What's the x value at that point? Negative 4. Now, x, because we're talking about domain, it's included because there's a point at negative 4. Find the rightmost point, which is bop, there it is, which is at the x value of 3. Now that circle right there means it's not included, which is why I did not put an equals to line underneath my inequality symbol. There's your domain. Range, we're going bottom to top. So there's the lowest point. The y value at that point is at negative 5. So the range starts at negative 5. And now once again, that tells me that that point is not included. So I'm not going to put an equal sign underneath. The highest point is bop right there at positive 5. The y value is right there at positive 5. And once again, that is not included either. Domain and range. Let's look at number 5. Number 5 says, use the graph below to answer questions 5 and 6. A conservation group has been working to increase the population of a herd of Asian elephants. The graph shows the number of results. Shows the results of their efforts, Select the correct answer. Which relation represents the information in the graph? So which relation? Again, relations can be functions. Relation is just a set of data. So I want to know these points look like what in coordinate form? Okay, well this point is going to be at 1, 5. Because we went over, x value is 1, we went up between 4 and 6, which is 5. This point is going to be at 2, 6. This point is going to be at 3, 10. Okay, 1, 5, no. 1, 5, yes. 1, 5, no. 1, 5, no. Okay, B is the answer. All right, let's go to number 6. Number 6 says, what's the range of the relation? Range, again, is bottom to top. So the lowest point on the graph is right there. What's the y value at that point? 5. Okay, now we're going to go increasing, right? The next range, the next value for the range is going to be at 6. The next value is going to be at 10. And the next value is going to be at 15. Okay. Number 7, we're looking at a quadratic. Let's look at some key attributes of a quadratic. Again, this is called a parabola. Not a parabola, a parabola. There is your vertex. We know that that is going to be a maximum because it's an upside down parabola. We want to identify the x-intercepts, or I could say the zeros, or the roots, or the solutions. What does that mean? That means where does the graph cross the x-axis? Right there and right there. So what are those 2 points? That point, we go over -4, and we went up 0. That point went over 2, and we went up 0. Again, remember that every x-intercept has a y value of 0. Which, if we're looking at number 8, every y-intercept is going to have an x value of 0. A y-intercept is where it crosses the y-axis. Vop right there at 0. We went over 0, we went up 8. Go to number 9. Number 9 says, what is the vertex? All right, here we go. We're looking at this graph for number 9. The vertex, I already told you, is going to be the highest point on the graph. It's the changing point. So we are increasing, hit the changing point, and then we are decreasing. That changing point right there is going to be the point -1, +9. Is a vertex a maximum or minimum? I already told you it's a maximum. Identify the range. The range goes from bottom to top. These arrows indicate that it goes from -infinity, and it goes to the highest point, which is that point right there at y value of +9. The domain, these arrows indicate that that graph keeps going, right? So it's going to start at -infinity. It's going to go to +infinity. Okay, now once again, if you write an infinity symbol, it cannot be equal to infinity. It says evaluate f of 1. F of 1, I'm asking you to tell me what is the point where the x value is 1. So we're going to go over to 1. We go up. There's the point right there, which is at 1, 5. So I'm going to say the point 1, 5. What are the zeros? Again, that means x-intercept. X-intercept. So where does the graph cross the x-axis? It crosses it at x equals -4. And it crosses it at x equals +2. Is the graph increasing or decreasing over the interval from 0 to 2? Well, here is 0 to 2. Is the graph going up or is the graph going down? That was hard. It's decreasing, right? Okay. Number 16, we're looking at a different relation here. So I have the table of age to shoe size. Number 16 says determine if it's a function. So again, if it's a function, none of my x values can repeat. Alright, so I'm looking at my x values, my domain, they cannot map to a different y value. So I have a domain of 6, 9, 12, 15, 18. Perfect. Yes, it's a function. Okay, so it says identify the domain and range. The domain is all the x values. Now, this is a discrete relation. Okay, it's a discrete relation because all I have is points. It's not continuous. So all I'm going to do is going to bracket, list out my x values. 6, 9, 12, 15, 18. Writing them in ascending order. So least to greatest. Same thing with my range, right? This is a discrete range. So write them from least to greatest. So 8, 10, 10.5, and 11. Now notice I only wrote the 10 one time, even though we have 2 of them. Looking at number 17. Number 17, the list represents the number of cars sold and the bonus received by the salespeople of a car dealership. So I want to, again, identify if it's a function and then list out the domain and range. So I'm looking at my x values. Do any of them repeat? No. So yes, it's a function. Domain, again, this is a discrete set of data. So 1, 2, 3, and 4. with the bracket, range, y values, so 50, 50, 100, 150. And again, I'm only going to write the 50 one time. Number 18, this is a mapping. So what that would look like if it was not a function is I would have two arrows coming off of the same x value. In this case, I have one arrow coming off of it, one arrow coming off of it, 1 and 1. So yes, it's a function. Domain, negative 2, 1, 2, and 7. Range, negative 3, negative 1, and 9. Number 19, we're looking at an ordered pair. Which set of ordered pairs does not represent a function? So now I'm looking at which ones repeat. So here we go, 5, negative 1, 1, and negative 7. None of those repeat, so that's a function. 5, 5. Let's keep going. Negative 2, 5, 1, and 4. 0, negative 3, 6, and negative 7. So again, this is the one that is not a function because my x value of 5 repeats to a different y value. Number 20 says, find the x-intercept of each line defined below and compare their values. Okay, so the x-intercept is where it crosses the x-axis, meaning that I have a y value of 0. I have a y value of 0. So what I'm going to do to find the x-intercept of line A is I'm going to plug in 0 for y. I know it has a y value of 0. Instead of writing that y right there, I'm going to write 0. So I've got 2 times x plus 0 equals 8. And now I'm solving for x. Okay, well 2x plus 0, anything plus 0 is just 0. So 2x equals 8. Solving for x, I'm going to divide by 2 on both sides, and I get x equals 4. So the x-intercept of line A is at positive 4. X equals positive 4. The the x-intercept of line B is given to me. It's that point right there, negative 6, 0. So the x-intercept is at negative 6. Therefore, the x-intercept of line A is greater, right? Because 4 is greater than negative 6. Sorry, can't see that. The x-intercept of line A is 4. The x-intercept of line B is negative 6. Therefore, the x-intercept of line A is greater than the x-intercept of line B because 4 is greater than negative 6. Number 21. Model the function rule, y equals 2/3 x minus 2 at the table in a graph. Okay, oh my goodness, there's a fraction. No biggie. What we're going to do is we're going to plug in negative 1 in place of x. So I've got y equals 2/3 times negative 1 minus 2. Because we want to find the y value. So we've got this negative 1, we're going to plug it in place of x to figure out what y is. 2/3 times negative 1 minus 2 is going to give me negative 8/3, or I could say that is negative 4.67. I'm going to do the same thing with 0. I've got 2/3 times 0 minus 2. Anything times 0 is 0, so 0 minus 2 is negative 2. I'm going to do the same thing with a positive 1, so I've got 2/3 times 1 minus 2, which gives me a negative 4/3. In decimal form, that's going to be negative 1.33. So now we can plot these points, right? I have a point at negative 1, negative 4.67. So we're going to go over negative 1. I'm going to go down negative 4.67, which would be about right in there. I've got a point at 0, negative 2. I've got a point at negative 1, negative 4.67. There it is. Negative 0, negative 2. And I've got a point at positive 1, negative 4/3, which is about negative 1.33. Should be about right in there. Okay, now can I connect those? No, it's a discrete graph, so I'm not going to connect those. Number 22 says find the range given that domain. So what I'm asking you to do is take that x value, plug it in. So I've got f of x equals negative 3 squared plus 4. Negative 3 times a negative 3, that's what the squared means. Negative 3 times negative 3 is a positive 9. 9 plus 4 is going to give me positive 13. We'll do the same thing with a negative 2. So I've got f of x equals negative 2 squared plus 4. Negative 2 times negative 2 is a positive 4, plus 4 is a positive 8. Do the same thing with a positive 2, so f of x equals 2 squared plus 4, which is 4 plus 4, which is 8. And then a positive 3, you guessed it, is going to give me the same thing right here. I've got a positive 3 squared plus 4, which is 9, plus 4, which is 13. So the range is going to be 8, just write it one time, and 13. Just write it one time. Alright, let's look at the last two. Number 23. We want to find the domain as a set of x values, and it's all the possible input, right? These all mean the same thing, or the independent variable. So the domain is a set of all the x values. It's all the possible inputs and the independent variable. The range is the opposite. The range is the y values. It's all the possible output and the dependent variable. There you go, peeps.